So, question number 1. What does it mean for a method to return a value? 2 minutes. Thirty seconds. All right, survey says return value is what an invoked method will be equal to. It is usually indicated by the keyword return, or in some language is implicitly done with the last line of a method. Cool. Compare yours to mine. What questions do you have? Yeah.
Why do you specify equal to? Because I know within React that we're learning, sometimes it's not specifically like 1 plus 1. It'll also return like HTML or something like that.
Sure.
Am I getting too far?
So in that case, it's great. Exactly the kind of question we're looking for. Thank you, Samantha. So in React, I've got a dogs method that doesn't return a string or a Boolean or something. It returns like mapped HTML. So I might return this dot dogs dot map and then take the dog and I'm returning dog or something like that. That's what you mean?
Yeah, something to that extent.
Cool. So what I am saying when I do this even goes two layers down because we have the return from the map and the return from this function itself. What this means is when I do this dot dogs, this and the output of that map are the same thing.
Okay.
It's anytime I'm using this, I could also swap it out for this long ass expression because they're identical. Great question. What about when I put something or I console log something? How is that different than returning? What's different there? Yeah, Miriam.
Because return break you out of the little loop, so you can use return all the place.
It absolutely does. Returns will break you out of things. Whereas like puts won't. It's not the only difference though. Yeah, Patrick.
Puts is just
putting it to the council, that's not literally used anywhere else other than our eyes.
Indeed. That's for outputting something to the screen. Console.log works the exact same way. So it's not equal to invoking it. They're not the same thing. It's this completely other thing where I might want to output something to the screen and return it. So if I'm in Ruby, maybe I do something like puts, say, dog equals Bixby, puts dog, return dog. I might want to do something like that where I'm outputting as well as returning, but chances are, I'd much rather do something like that. I'm outputting the return value of that method. Cool. Other questions about returning? Cool. Next question. What is the difference? What is the difference between a procedure, a function, and a method? It's purely academic difference, but hey, that's what this whole class is. So give it your best shot. 2 minutes. Go. Wrestling this shit into words is hard. That's why we're doing it. All right. So there's mine. Procedure is a set of statements that can be repeated on demand. A function takes inputs and transforms them into outputs. A method is a procedure that is stored on an object. Questions about those? That's dense. You're not asking me questions, I'm assuming you just know all this shit. Toby, what you got?
So if we're talking about a function that takes an input and transform it, is it still a pure function?
I see what you're saying.
Because you would say transform.
You're not mutating. You're saying, with this information, I will generate this thing, but you're not necessarily mutating the actual input. Good distinction. Yeah?
So a function is a procedure, a method is a procedure?
Function is not a procedure. A method is a procedure. Another way to think of this, our function takes this and this turns it into that. I take 3 numbers in and I give you their sum. That's a function. Function is a math word. Like f of x equals y equals mx plus b. That's a function. Same kind of thing here. So, by the way, for those of you who did that kind of stuff in math, we do f of x equals mx plus b. Could we not also write that? Function that takes in x returns m times x. Wow, interesting. That's the math connection to programming, if you were wondering. It's like you're getting towards the end of the program, it's like, I was told there would be more math. Okay, so that's a function. How is that different than a procedure, though? Who can tell me?
A procedure doesn't have an output.
It doesn't have to. So things that rely on side effects, like console logging, putzing, printing something out to the screen. If I just have some group of things that I want to be able to do a bunch of times, for example, maybe I've got a counter and it starts at 0, and I have an increment method procedure that sets counter equal to counter plus 1. And then I call it increment a bunch of times. Procedure. It's just repeated code that like I want to store in a easy thing. Doesn't necessarily return something, although it often does.
So would a map be more of a procedure?
A map is, well, depends on how it's being done. So the way we did it in Ruby and the way we do it natively in JavaScript, or we have something dot map. That's not a function or a procedure. That's a method. It's a method on the array class, or on any instance of an array class. We have that method that can operate on its data. There's also pure functions for that, though. So if you use the Lodash one, we have the transformation that we want to do on everything, and then we have the data that we want to put into it. Method, function. And then what's a method?
Procedure?
That is
Done on an object.
is done on an object, it's owned by the object. So I have an instance of a class that has state and behavior. Those behaviors are called methods. A lot of times these three things are indistinguishable from each other. And you'll see people just use these words interchangeably. Procedure is also called a subroutine. Same shit. But there is a difference, and that's what they are. Cool. Next, what's the difference between a hash and an array? Give your best shot. Go. All right, cool. My answer was a hash is a collection of keys and their values. Values can be accessed randomly, that's an important part, by their key. An array is an indexed list of values. Elements can be accessed by their index. Hashes and objects have different operations that can be performed. That should have been arrays. Hashes and arrays have different operations that can be performed on them or by them. Cool. Compare it to yours. What questions do you have?
You said randomly.
Mhm.
It was important to note that. Why is that?
Because not every data structure can be accessed randomly. Was anybody here when we talked about stacks and queues? Those are data structures that can't be accessed randomly. So in the case of a stack, think about like a literal stack of plates. You can add one to the top. You can take one off the top. Imagine you're looking down at this stack of plates and they all have different pictures on them. And you want to know what picture is on this other one. What would you do? Take it off until you get there. That's exactly how you work with that data structure. I can't do that. In arrays, I can access any one of them, but I have to know which index it is. With a hash, I get to put some kind of label on it. Pretty cool. Another thing that I didn't put this in my definition, but another thing that's important about arrays, order is important. Order is not important in a hash. So it's not alphabetized or anything like that. The order is not significant. Is in an array. Anybody happen to know the vocab word for an array-like thing where the order isn't significant? Ooh, super good guess. Dictionary is a lot like a hash. Collection's in the ballpark. There's a slightly more academic word for it. Nope, good guess. Tuple is a hash with unlike data types. It's a list.
Can a tuple be an array too?
No, like the math definition of an array is every single one of them is the same data type. Actually, this is a good tangent. Does anybody know why arrays indexes start at 0?
That's their key.
Kinda. Because it's not offset. Bravo, Danny. So, brava, rather. So, I have some numbers in an array. If we go through all of the magic to when it gets down to your hard drive or your RAM, we say is that this array starts at memory address, let's call it 5. We need to know how big each of the things in the array are. So let's say each one of these takes up 6. 6 what? Who gives a shit? Doesn't matter. But I know that every single one of these slots takes up 6. So I say that next one's going to be 11. Next one's going to be at 17. So this is on the hard drive. Starts at 5. Next element's here. Next element's here. What we say is that this first one here that matches up to 1, that is the address of the array and is not offset. If I want the next one, I go to the address that the array is stored at, offset by 1. or if I want the last element, I want it offset by 2. And that's why in like a computer science array, these all need to be the exact same size because we need to know how big that offset actually jumps. So in some languages, they'll have like 17 different kinds of number. They'll have like a tiny int, they'll have a regular integer, they'll have a floating point integer, they'll have a big int, all these different ways to say number. And the reason why is that they all take up different amounts of space. Cool. Fun tangent. Other questions about difference between a hash and an array?
What was the vocabulary you're in?
List. Yeah. Yeah.
Can it be accessed randomly by value or only key?
Only by key. Even when you have some like cool utility that'll let you like search by value, the values don't have to be unique. The keys do. And so if you do something like find, you'll find the first match. What would you do if you wanted every value match for something? Should all know this.
I'm not.
Select or filter. Same thing. What's the difference between a hash in Ruby and an object in JavaScript? Who said that? Cool. Right answer, Rocky. Nothing. It's like very poor choice of words. An object in JavaScript is a hash. Hash with like a little bit of sauce on it, but it is not an object in the. Oh, actually, this is the next question. All right. On that note, what's the difference between a hash and an object? Go for it. And I mean this like actual objects, not JavaScript objects. So nothing isn't the answer to this. I heard a lot of people stop typing very quickly. Hey there, Damon. The exterminator shows up. I called the exterminator. All right. Time's up. So my answer. Hash is a collection of keys and their values. An object is a collection of state and behavior and is an instance of a class. JavaScript objects are more accurately described as hashes or dictionaries. Yes.
Is it wrong to give examples of what you mean
When talking code?
No. Although there are, I know there's some text screeners, which, by the way, these kinds of things show up in text screeners all the time. That's where I source a lot of these. That will give you menos puntos if you resort to examples. If you can't also do it with just words. Like a really common one is polymorphism. Explaining polymorphism without using an example. This is very difficult to do. But if you give a definition and then support it with an example, I think that is a greater level of understanding. I will say an example is better than, oh, no. Cool. Questions about hashes and objects? Yeah, Ben.
So in the last one, you said JavaScript objects are more accurately described as hashes or dictionaries. But then, like, I guess when you're talking code, you wouldn't be talking in a coding language, right?
Correct.
Like, it'd be weird, like, if you're in JavaScript, to be like to call something a hash, but that's not even a thing in JavaScript, right?
Right. But you're bringing a new person onto the team, and they go, these objects aren't like any objects I've ever seen. And you go, oh, it's because they're not. Yeah, Parker.
In mine, I said that the object is an instance that points to the behaviors or that points to the attributes initialized in a class. Is that true or not? I was sort of thinking about how when you have an array of all the instances, it's like their ID and then their attributes.
Sure. So let's specify that a little bit more. When I have a class, I have a cookie cutter that I can use to make different cookies. This one can be purple, and this one can be green, and I can have red ones and all kinds of other things, but they all have the same shape. Class objects. The class is the shape of something, something that has these behaviors and has this state. Now, my state, this thing's state is blue, this thing's state is green. They don't have to have the exact same state, but both of them have a color. That's the thing they share in common. That's what a class does. Now, we can also say that, like, this is where the metaphor falls apart, that with a class, the class itself is technically an object and has its own state and behaviors, and we call those class methods, static methods, that kind of thing. Static properties, class variables, all that stuff is, you also have that stuff available on the cookie cutter itself, which is kind of weird. But what these objects have is this shape, and they know they were created by this cookie cutter. But past that, they can't actually see the class methods or the class properties directly. Not allowed. They can ask the class for its state and behavior, but they can't just see it because they were made by that cookie cutter. Okay, what from that was confusing? Because I'm sure there was something. Yeah.
Why are we differentiating between a hash and an object anyways? Aren't they just like completely different things? Like to me, they're not even remotely the same. Like why would we confuse these two things?
Sure. Because the values that you're storing on a hash, well, not in Ruby, but in plenty of other things, can also be behaviors. So like in JavaScript, for example, and this is like where they got their name from. If I have an object, or a JavaScript object with the color blue and a method called bake, that looks suspiciously like an object. And in fact, we can even sort of kind of use it like one via the prototype system in JavaScript. I can make another object that is this shape by making this its prototype. Weird. So that's why it's easy to get those two things mixed up. Because that is state and behavior, but it wasn't made by a class. And then JavaScript really fucked it up by introducing the class keyword, so it looks like you're making an instance of a class, but actually not.
Use the phrase static methods
Mm-hmm.
and properties. That equates to, in Ruby, to
Mhm.
class level variables.
Yep.
Or not variables, but methods and.
So yeah, when I do add at all and initialize it to this, what do we call add at all? Hmm?
Class, well, yeah, class method, but it's also.
That's not a class method.
Or
That's variable.
Class variable. Cool. And then when I do def self.all and then return add all inside of that, what is this?
class method.
Cool. That's a Ruby only thing. Nobody else calls it that. What everybody else calls this is a static property and a static method. Ruby tends to eschew like more formal language and go with the friendlier class variable and class method. Static property, static method is the formal term for it.
So then what's an instance method and instance variable called?
That instance method, instance property, or just a method and property. Cool. What else? All right. When should you use map, select, reduce, and find? 4 different answers. All right. My answer. Map is transforming a collection into a different collection of the same size. Reducing is accumulating a collection into a single value. Selecting or filtering, same thing, is retrieving only the items from a collection that match a condition. Finding is retrieving the first item from a collection that matches a condition. Select filter and find are almost identical. The difference is you only find one with find. You always find a collection with select and filter, even if there's only one match. Okay, compare answers. What questions have you? This different collection of the same size thing, you should have that one in your soul. Because the number of times you're like, is this which one is this? If you can answer like, is it going into one thing? Is it going to be the same number of things that I started with? Or is it going to be the same or fewer? That'll answer your question like 9 out of 10 times. Yeah, Finn.
In all of those definitions, you use the word collection rather than array or hash. Does
Correct.
that mean that you can do it with either? I thought some of those were random.
Ah, great question. So, all three of these, I would say, I'm using collection for because we're talking about these a little bit more abstractly. In Ruby, I can do all 4 of those on hashes or arrays. In JavaScript, I can only do these on arrays. I can't do them on objects. Unless I'm using good old Lodash. That's actually the biggest distinction. Well, yes. Biggest distinction between Lodash's map and filter and all that kind of stuff versus the one you just get at a JavaScript directly is that map will take anything that looks collection-like. That includes maps, that includes objects in JavaScript, that also includes strings. A string is a collection of characters. And so you can pass any one of those things into a Lodash map. And that's a little bit more of an accurate use of the concept. Yes?
When I think about reduce, I get stuck on like having it sum all the values of something.
Mm-hmm.
Yeah.
Okay.
I get stuck there, but can you also use it to like find the highest value? Like, could you use it
Absolutely.
in a similar way to maxify?
You absolutely could. In fact, reduce is a Swiss Army knife. There's not much you can't do with reduce. So yeah, you can totally find the most of something. So you're iterating through a collection, find the first thing, and you go, is this more than whatever the stored value is? You go, cool, well it is. The first time through, maybe it's nothing, or it's whatever you initialized it to. So you go, okay, cool, well now it's that. And then you go to the next item in the collection. Is this more than that? All right, cool. It's not, then just return the one that I had already. And so we can do that so that we're only getting the one that's the most, or the least, or the longest, or whatever. We can also do this, use reduce to find out if something has any matches. So we start with false, and then we're testing to find if something's true on every item in the collection. If it's true, we return true, and then you just keep returning true every time. So if I reduce that, I have a single Boolean value that tells me whether or not there was any match in there. And this is how we would like recreate map or filter or something like that with reduce. It needs to be a single value. That could be an array or a hash or something like that. It can be a complex value. It just needs to be one of them. So we could like be building up an array and like pushing new values into that and that kind of shit. That's fair game for reduce also. But that's what makes that one a little bit more confusing and a lot more powerful. Cool. Other questions about these 4? Neat. Onward. What's the difference between a class and an instance? of a class. I imagine that basically all of you probably know this. Putting it into language, man, it's rough. Give it a go. Somebody asked that in an interview. What do you say? All right, pencils down. Class is a blueprint for creating objects that share similar state and behavior. An instance is a concrete implementation of a class, also called an object. Questions? Yeah, Ben.
Maybe you have this coming in the future, but can you like throw out a one sentence definition of inheritance?
Sure. Inheritance is when a class assumes the state and behavior of another class. In addition to its own. Yeah.
What do you call the instance of concrete implementation?
Sure. Because a class, like by itself, doesn't do anything. Doesn't do anything until you make it concrete. Now, where this gets like geek, is that in a lot of languages, including Ruby, classes are also objects. That's why they also have state and behavior. But it's that part of it that the fact that classes are objects is why they can do that, not because they're classes. So another way to put it would be, I can't eat this. I can't eat that. Or another way to put it would be, what color is this? Well, it doesn't really have a color because I haven't made it concrete yet. Other questions? Onward. What's the difference between an instance method and a class method? Pencils down. My answer was instance method belongs to an object and cannot be called in the class itself. Class method is owned by the class and cannot be called in any one instance. So this is related. What color are you? I don't have a color. I'm just telling you how to make things that have certain colors. But like in Ruby where we have all, we keep track of every instance that we've made. I can see all from the class. Any particular object can't look up at all. Can look up dog.all, but it doesn't own it, doesn't have it on itself. Questions about that?
Do all class methods have to do with all the instances of the class?
Say that again?
So for any class method that you call, is it dealing with information from all the instances?
Not necessarily. It could if, for example, you were keeping track of everyone that you made with like that at all like we were doing before. If it's keeping track of that, then yeah, it can do anything it wants with its like all property. But that's why it can do that.
Could you write a method that does something else?
Like what?
No, I can't think of any example, that's why I'm asking.
Sure. So, other than at all, classes are not aware of their instances. You could maybe put a property on a class that's like, have I been instantiated? And in the constructor for the class, you set that to true. And so maybe you're keeping track of whether or not if you've ever had a concrete implementation. I don't know when or why you would do that, but you can do that kind of thing. Other questions about this? Yeah, Ben.
Sorry, just to like kind of tag on that question. So like, that's an example of another class method other than that at all?
Yeah, that could be. Class methods are really commonly done as like utilities. Or let's say I keep all my dogs on a API on the network. I might have a class called like dog capital D dot fetch all, and what it's responsible for is returning back, going across the network, getting all my dogs, and then returning back an array of dog instances. That'd be pretty common. Oh, fetch one would even be a pretty common class method. Where you go dog.fetch1 and I pass it an ID, and it goes across the network and gets something for me and returns back a dog instance. That'd be pretty normal. Formatting. For those of you who've done JavaScript before, every time we do JSON.parse or JSON.stringify, both of those were class methods. So these take in a JSON string or take in a JavaScript object and return it. They're not really specific to like an instance of the JSON class or anything like that. Not really how it works. It's just saying that, hey, since this is related, we'll just kind of attach that on also. Utilities, very commonly done as class methods.
Oh, no, forgot.
Yeah.
The language used in this description.
Yeah.
Belongs to and is owned by. Can that only be used with methods, or can that be used with properties and attributes as well? I've heard the phrase a property on an object. So those are three: on, belongs to, and owned by.
Semantically equivalent.
What gets used?
What are the properties on this instance? What properties does this object have? Can you set this property on this object? All those are fair. you call this method on this object. What methods does this object have? Does this have the whatever method on it? Has it inherited that? So I'd say all of those I would hear equally common.
But you wouldn't say the class owns an attribute property. So the owns and belongs to for properties and attributes, not so much, those are usually on and have.
Careful with attribute there. So if we're sticking with formal language, an object has a property and it has a method, not attribute. Something like an HTML element has an attribute. And these are like minor academic distinctions. If you said the attribute of an object, everyone would know exactly what you're talking about, and they probably wouldn't even look at you twice about it. But formal language, properties and methods. It's totally fair to say it owns this property or it has this property, or all those mean the same thing.
So instances don't have attributes, instances have properties too? So classes and instances in formal language both own
Properties.
properties.
Because a class is also an object.
Okay.
That's why. Cool. What else? All right, let's do a couple more. All right, what is a gem file, a gem file, and a gem file.lock? For the JavaScript inclined, what is a package package.json, and a package json.lock? Exact same things. NPM ripped it off of gem. Go for it. Cool, pencils down. Gem is a collection of code that has been packaged for easy installation and reuse. A gem file is a list of gems, their approximate versions, and which environments require them. And a gem file lock is a list of gems, their exact versions, and which environments require them. Yeah.
For me, gem file and gem file.lock seem like the exact same thing.
Cool. So I'm going to add one more thing to my definition. Their exact versions as well as those of their dependencies. All right, so let's take a look at the difference between the two, and hopefully that clears it up a little bit. All right, so if I go and make a new node project, all right, nothing in this file. I make a new npm project. Cool. So now I have a package.json file. It has some metadata about my project right now. All right, fine. I want to install bcrypt. So I npm install bcrypt. Cool. Now, if I take a look inside this, it says, all right, this app depends on bcrypt with a version of 3.0.7. I think starting with a caret is or greater. I never remember it though. Semantic versioning symbols. Why is there a caret in my package.json? Okay. All right. Newer patch level, a newer minor or version. Got it. So these three numbers here, they actually mean very specific things. First one's called a major version. Major version is not backwards compatible. There might be something in version 2 of bcrypt that was completely removed in version 3. You cannot expect those to necessarily work together. Second one, it's called a minor version. This is within a major version, just adding new functionality. So version 3.2 can depend on something that happened in version 3.1, but otherwise, we're just adding new things onto it. Still getting backwards compatibility. Everything that was written for 3.7 should also work with 3.6, 3.5, 3.4, and so on. Last one is called a patch version. Patch version is I made a mistake in this and I fixed it. This is like bug fixes and stuff. Technically a different version, but we're not talking new features. We're talking about delivering the thing that we said that we were delivering in the minor version. We just noticed that we typoed or something like that. Major, minor, patch. If I put a tilde in front of this, I'm saying I will accept 3.0 and whatever patch version is newest. If I do a caret, I'm saying this, or if you have a newer minor version and patch version. I'll take the newest, whatever you got. Still needs to be version 3 though. Cool, so that's what I put in my package.json. If I look in this, whoa, what is all this shit? ANSI regex balanced match. Well, hey now, bcrypt, brace expansion, what is all this stuff? It's dependencies. If we look in the package.json for bcrypt, probably see all these. So let's go exploring. I go into bcrypt. Oh, weird. This has a package.json also. And it has contributors. It has dependencies. And those have dependencies. And those have dependencies. And so your package lock file gives you all of those with exact versions of each of them, not about this or up to this or at least this. And so we looked at bcrypt, for example. We're getting specifically 3.0.7. We didn't find a newer one. Who cares? Yeah.
Question. So is the yarn.lock file the same as the gem file?
Exactly.
Holy fuck, React has a shit ton of stuff. That is atrocious.
Indeed.
10,000 lines of gem shit.
Yep. So who cares? Why do we have both of them? We didn't used to. It was actually the creation of Yarn. Yarn had lock files, and everybody switched over to Yarn, and NPM all of a sudden was like, never mind, we have lock files too. That was like a really interesting week to be a JavaScript developer when all that was happening. Why? Why did so many people think lock files were so badass? They're willing to switch package managers, use an unconventional package manager, doesn't come installed with Node automatically. Why?
Is it because when, like, a client or somebody downloads, does bundle install
Mhm.
or npm install, this way they get all of the exact things they need rather than like approximations?
Exactly. Another way to put this is order dependent. So if I say, let's say I'm developing this, and I install this, I'm working with that, okay, cool. Then 3.3 comes out or something over the course of me developing it. But this is the one that I installed. It still fulfills that criteria. It doesn't necessarily constantly looking for newer versions of it. So then you run into this situation where like, well, if you installed the older version first and then installed this one and installed this one, so now the order that you installed the stuff in becomes important. Yikes, that's hard to replicate. Or if there's some bug in a patch version that you were actually depending on, and then they fixed it in a later patch version. And to your point, a client, another developer on the team, you bring somebody new on, they npm install, yours works, theirs doesn't. Uh-oh. So by having a lock file, now we have deterministic package management. When you npm install, and this is the same thing when you bundle install with Ruby, it doesn't actually look at this. It only looks at this if this doesn't exist. And then it generates this and installs all of these things. If I have a lock file and I give you my repo and you install it, it just looks through all of this. It ignores the dependencies in the package JSON. This is just instructions for how to make the lock file. Samantha, what other questions do you have about that?
That actually covers a lot.
Hell yeah! I'm a good explainer.
So in React, like, is every single one of those gems in your yard lock file like already ready to go? Whereas like in Ruby, it has a gem file and like you'll have to go comment shit out that you may want.
Oh yeah, there's no similar concept in NPM. Like it could be. I don't like that in that convention in gem files. You could do it. So what it would look like is, let me find. Let me go to the developer for one. So I have this package JSON file, and I have all these dependencies. The equivalent to how Rails does it is I just comment out all of this stuff. And, oh, actually, shit, it won't let me do that. That's why it's red. Because this isn't JavaScript. There's no comments in JSON. So you can't comment stuff out. I still think it's a better system, though. It's like, if it was, then like, oh, here's a bunch of options that you could have and uncomment them if you want them. I think that's sloppy.
Can you flip back to your definitions page?
Mm-hmm. Yes, I can. So, gem file.lock. if you are currently a Rubyist, swap out package for gem, JSON, package.json for gem file, package JSON lock for gem file lock. The exact same thing. One thing that we didn't talk about is environments on this. You can have stuff that is needed to build the project, but not to run the project. It's called dev dependencies. So this would be like Webpack in React. We need Webpack to build the project. You absolutely don't need it to run the project. What Webpack does is it makes a JavaScript file that'll just run on a browser. No other dependencies needed. In fact, you could say that in a React project, everything is a dev dependency because it just ends up pooping out a JavaScript file that has everything in it. And it might be a 2 meg JavaScript file or something like that. But that can be helpful for something like Heroku, Heroku will only install your production dependencies. It doesn't care what you needed in order to develop it, because all it does is just run whatever you give it. Cool, let's do one more. What is a one-to-many relationship? Many-to-many? Go for it. All right, pencils down. A one-to-many relationship indicates that an entity can relate to many instances of another entity, but each one of them only relates to one instance. In a many-to-many relationship, each entity can have an arbitrary number of relationships with the other entity. This skips ahead a little bit. So, by the way, one-to-many, many-to-many, ERDs, this doesn't have anything to do with software. This is a very abstract concept. So you might say that one manager has many employees, but every employee only has one manager, or something like that. This predates digital ways to represent these relationships by quite a bit. And you can do this exact same thing with filing cabinets and all kinds of other stuff. Library science. We're talking about how concrete things relate to each other. And we derive rules from this. This is what my information systems degree was just 4 years of this shit. So in a database, though, we do it a little bit differently. There's like a specific way that we're representing this relationship. And as you're all aware, I can say this when I'm just talking about concepts. Can't do that in the database. What did I have to do instead? Join. I had to do a join table. So, all right, well, now every manager can have many employees, but each employee can also have more than one manager. So we flip the crow's feet around and do that join in between. How this works under the hood, which is kind of what the next question is shockingly simple. Oops, what did I just do there? There we go. A dependent table will store an independent table's primary key as a foreign key. That's it. That's all a relationship is in a database. So when I say one-to-many, I have my employees, Kyle, and 2 is Ahmed. And then we have managers. 1 is Josh, 2 is Brian. And then I'm also keeping track of who my manager is, and both of us report to Brian. All this means, this is a primary key in this table. If I put 3 in that column, the database throws an error. That's it. All it is. These have to be unique. These have to be unique. These don't have to be unique. There's no other intelligence behind this. If I put 2 in, but I got that 2 from a completely different table that also happens to have a 2, database does not throw an error. It's just a little sanity check on that. Now for many-to-many, the thing that changes is I have this like manager employees join. And all I'm storing is unique instances of 2 of them. So I say that Josh manages Kyle. Josh manages Ahmed. Brian also manages Kyle. It's unique occurrences of these. Now, the thing that will throw an error, or should throw an error, is if I try to say that Josh manages Kyle a second time. That's not unique. It's the combination of them that needs to be unique. Womp womp. Each entity can relate to many instances of another, but each one of them only relates to one instance or arbitrary number. Each of these 1s and 2s is going to show up 1 billion times in this table, as long as the thing they're paired with is unique. Ta-da. Questions about that? Everybody's brain's good and hurty? Cool, thanks for coming.